Hi, let's continue with section 1.3, applications and problems solving. A, solve applied problems by translating to equations, and 3, solve basic motion problems. To begin, to familiarize yourself with the problem, if a problem is given in words, read it carefully. When we go through it for example, if we were in lecture, we might go through it a bit quickly, but really give yourself time to read it. Maybe 3, 4, 5, 6, 10 times, whatever number you need, but read it for sure more than once. Next, you want to list the information given and the question to be answered. Maybe you might want to underline what is the question. What are you looking for? Next, you want to choose a variable or variables to represent the unknown or unknowns, and clearly state what the variable represents. Be descriptive. For example, let L be length in meters, T be distance in miles, and so on. Next, you want to make a drawing and label it with known information. Also, indicate unknown information using specific units if given. You also want to find further information if necessary. Look up a formula at the back of the book or Google it. Or in a reference book, look up the topic using an internet search engine. Next, make a table that lists all the information you have collected. Look for patterns that may help in the translation to an equation. Think of a possible answer and check the guess. Note the manner in which the guess is checked. This will help you translate the problem to an equation. So let's go ahead and do an example. The problem reads, a 480-inch piece of pipe is cut into two pieces. One piece is 3 times the length of the other. Find the length of each piece. All right, so just to draw an idea, I have a piece of pipe and I cut it into two pieces and I want to find the length of each piece. I know the sum of it, so I know our first piece plus my second piece should equal 180. Okay, now let's talk about what it's telling us. It says that it's cut into two pieces and one piece is 3 times the length of the other. So our two pieces are the other and one that's 3 times the other. All right, let's familiarize ourselves with the problem. Let's make a drawing, a more involved drawing, noting the lengths. So I know one of them is the other, and the other is 3 times the other. So let x be the measurement of one side, and the other one's to be 3 times the other. Let's translate. From the statement of the problem, one piece is 3 times the length of the other, and the total is 180 inches. So I have x plus 3x equals 480. Let's go ahead and solve. X plus 3x is 4x, and 4x is equal to 180. We divide both sides by 4. 4 divided by 4 is 1, and we're left with 480 divided by 4. That gives us 120. So x is 120 inches. Check. Do we have an answer to the problem? No, right? We just know the length of one side. And what was our question asking us? Find the length of each piece of pipe. So I know one of them. So just to remind you of the drawing, one of them is 3x and the other one is x. So I know one of them. I know one of them is 120. What about the other? Well, I need to multiply it by 3x, right? So 3 times 120 gives us 360. So does that make sense? 360 plus 120? Yeah, that gives us 140. So it works out. So let's go ahead and write our answer. Whenever you have a word problem, you need a word answer. So we can say something along the lines of one section of pipe is 120 inches and the other section is 360 inches. And that is our answer. Next problem. The faculty discount at a bookstore is 15%. If a sweatshirt after discount was $32.30, what was the original price of the sweatshirt? And this is important to know because you want to make sure, especially when you're shopping, that you're getting the correct discount, that it's applied, and they're not doing something wrong. So we know if we want to find the percent, so let's say we take 100, 40% we multiply it by 40, and that will give us our discount, right? Remember to always change your percents to decimals. And you do it by moving the decimal point over to the left twice. So you move it to the left twice. All right, let's familiarize ourselves with what's going on. So note that discount is calculated and then subtracted from the original price. So let's think about what we would do. So let's take a guess. Let's assume that $40 is the original price. If you're trying to find the discount of 15%, remember you move the decimal over, to the left. I said right. So left. So you take 40 times 15.15, that gives you $6. So that would be your discount. So after your discount, 40 minus $6 or 0.15 times 40, you would get 36. So if we want to know the original price, which we said was in our guess was 40, let's replace 40 with our unknown because we do not know what the original price was. That is our question. What is the original price? So we have a formula made up, right? We have our original value minus the percent times the original value gives us our answer. Let's go ahead and apply it in the next slide. The sweatshirt price minus the discount is the sale price. And we have this here. So let S be the price. So we have S minus 0.15 times S equals 32.30, which is our price with the discount. All right. So let's go ahead and figure this out. Well, it might seem weird, but we already have everything we need. We multiply S and 0.5 so that we have S minus 0.15 S equals 32. Now we combine like terms. We can actually go ahead and subtract these. Think of this S as, the first S as a 1. So we have 1S. 1 minus 0.15 gives us 0.85. 0.85S equals 32. We divide by 0.85, divide by 0.85, and we get S is equal to, we get 38. 32 divided by 0.85 gives us 38. So that is our sweatshirt price. Sweatshirt price. And you can always check it out. So next slide shows us how we check it. So we have our formula, and if it's, note that 15% of 38 would be 570, and when we subtract 38, when we subtract 570 from 38, we get 32.30, which is what our problem said. It checks out. So our answer is the original price of the sweatshirt is $38. Let's do another example. You are constructing a triangular kite. The second angle of the kite is 3 times as large as the first. The third angle is 10 degrees more than the first. Find the measure of each angle. So read a couple of times You're working on your own, so you can pause the video if you'd like. Now, so we wish to find the value of these angles, and they're just telling us some pieces. Notice that they're all comparing it to the first. So our first angle would be x, and everything else is compared to that. So if we draw a triangle for our kite, we would have our x. We have one that's 3 times x, right? The second angle is 3 times as large. And then it also tells us that the third angle is 10 degrees more. So we have our 3 times and our 10 degrees more. All of it coming from that original first side. All right, 2. Let's go ahead and translate. To translate, we need to recall that the sum of all angles in a triangle is 180 degrees. So if we have a triangle, or I don't know, I can't think of another angle, a square, they're all going to add up to, no, just triangles. They add up to 180. All right, so let's go ahead and create a formula. We have our first angle plus our second angle plus our third angle equals 180. So let's go ahead and set that up. We know our first angle is x. Our second angle is 3x. And our third angle is x plus 10. So let's put that all together and create a formula, such as we see here. So we have x plus 3x plus x plus 10 equals 180. So let's clean this up. We have x plus 3x plus x, we have 5x, and then we have that plus 10. Let's get rid of 10 by subtracting both sides of 10. Minus 10, minus 10, that's gone. 180 minus 10 is 170. Lastly, we divide by 5, and we're left with x equals 34. The measure for the angles appears to be, so remember, 34 is just helping us find what we need. We know our first angle measure is what we're comparing it to. Then we have a second angle measure and a third angle measure. And these were the rules that were stated from the problem. So the first angle is 34. The second is 3 times. So 3 times 34, we get 102. And the third angle is x plus 10. So we get 44. So we can check it out and make sure that it adds up to 180. So the sum of all three numbers is 180. And the second angle is 3 times the first angle. So all of our statements check out. So our answer, we can say something along the lines of the measures of the angles are 34, 44, and 102. Next example. Apartments in Wanda's apartment house are consecutively numbered on each floor. The sum of her number and the next door neighbor's number is 723. What are the two numbers? All right, so let's think about how numbers work. And we know this, but we might not really think about it. So say we have these set of numbers. So let's put numbers there. We have 1, 2, 3, 4. How do all these numbers relate to one another? So let's say the first number is x. How would I get using x to the next number? Well, I would get to the next one by adding one more, right? X plus 1. Now we're comparing everything from x. X is our base. All right, how would I get to 3? I would get to 3 by x plus 2. Because if x is 1, 1 plus 2 is 3. How would I get to 4? X plus 3, and so on. All right, So our question is telling us that we're working to find out what the two apartment numbers are, but we know that they're working on consecutive numbers. So consecutive means right next to each other. And the sum should be 723. So if they're right next to each other, if our first is x, then our numbers would be x plus 1, just as we have here, where we say familiarize. The apartment's number are consecutive. So if we let x be 1, then the next one would be x plus 1. Okay, let's go ahead and work this out. So I know if the first one plus the next one, the sum should be 723. We have a formula now. I have x plus 1 equals 723. This gives us 2x plus 1 equals 723. Let's go ahead and work this out. Minus 1, 722 divided by 2 divided by 2. We get x is 361. So that means our first apartment is 361 and the next one is 362 because we're adding 1. And they check out. 361 plus 362 is 723. So we can say as an answer something along the lines of the apartment numbers are 361 and 362. Last example. An airplane has been instructed to climb its present altitude of 12,000 feet to a cruising altitude of 31,200 feet. The plane ascends at a rate of 3,200 feet per minute, or you can think of 3,200. How long will it take for the plane to reach the cruising altitude? So let's start off by familiarizing ourselves with the information. So if you need to, read it a couple more times. So we read the problem carefully and try to organize the information. So we're starting at 12,000 feet. We're cruising. Our goal is to get to cruising altitude of 31,200. And we know that we can climb at a rate of 3,200 feet per minute. How long will it take? That's what we want to find. Well, let's begin to find what is the distance between starting and cruising. What is the difference? We see here that is 31,200 minus 12,000. We get 19,200. All right. So to translate, we use the motion formula, distance times rate times time. So let's substitute let's substitute 12,200 for D and 32 feet per minute by R. So we have D is equal to R times T. All right, so we have to just simply solve by T. So we have to divide by 3,200 or 3,200. And we get that our answer is T. So our answer is it will take the plane 6 minutes to reach cruising altitude. All right, that's it for section 1.3.